Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with lesson number 22 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the most excellent Sunfounder Raphael Raspberry Pi kit. The Sunfounder Raphael Raspberry Pi kit. Okay, most of you guys already have your kit. If you don't, look down in the description. There's a link over to Amazon. You can hop on over there and pick up your gear. But enough of this shameless self-promotion. Let's talk about what I am going to teach you today. And what I'm going to do is I'm going to show you the homework assignment solution for the assignment that I gave you in lesson number 21. And that was to take the HC-SR04 Ultrasonic Sensor and to use it to measure distance. Now, what I taught you in last week's lesson, was how to hook up the HC-SR04, and you can see over here, here is the wiring diagram. We're coming off the Raspberry Pi. We're using that expansion cable and that expansion board, and then we've got the pins over here, and we basically had a really simple connection. We have the leftmost pin, when the sensor's looking at you, is the voltage, which is going to be 3.3 volts. Then we have the next pin is the trigger pin, the next pin is the echo pin, and then the fourth pin, the right pin, was ground. And so we've got trigger and echo. Trigger was hooked to GPIO pin 23 on the breakout board, and echo was hooked to GPIO pin 24 on the breakout board. So that was pretty easy to get set up. And then what I did was I showed you how to code this so that you could measure ping travel time. You send a signal to the trigger pin, and then when the device gets that signal, it then triggers a ping. It sends a ping. Now, it tells us right when the ping sends, it sends the echo pin high. The echo pin stays high until it hears the return of the ping, and then the echo pin goes low. And so what we saw is if we sit and we watch the echo pin, the amount of time that that echo pin is high, that is the what? That is the ping travel time. And so we wrote a little code to show you how to do that. And basically we saw that as the target gets further from the sensor, the ping travel time goes up. And then as the target gets closer, the ping travel time goes down. And as we played around with it, it seemed to make sense, like it was moving and acting the right way. Now, what your homework assignment was to take that basic foundation and to go out and use the sensor to measure distance. All right. Now, how many of you guys were successful? If you were successful, leave a comment down below. I am legend. And if you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. Okay. Main thing is you tried. If you weren't able to get it, I'm going to show you how to do it today. And so how am I going to do it? So what I'm going to do is I'm going to just jump in and start banging out code, right? No, we're trying to teach you how to think like an engineer, and an engineer always does what? An engineer always does what? An engineer always starts by sketching things out on paper. And so that's what we're going to do. We're going to sketch things out on paper. Now, this is what I need you to think about. What do we have? We have time. We have time of the trip. We have ping travel time. And what do we want? Distance, how far the ping went. So how do we do that? I kind of gave you a hint last week. If you're traveling 60 miles an hour, which is a rate, for 3 hours, which is a time, how far did you go? 180 miles, which is a what? Which is a distance. And so what you can see is, and hopefully you know this, but what you can see is D, the distance you travel, is equal to the rate you are traveling at, r. So d is equal to r times t, the time that you were traveling. Really easy. D, the distance, is equal to r, the rate, times t, the time. R, 60 miles an hour. T, 3 hours. What's the d? Distance, 180 miles. All right, but now what we got to think is we got to kind of think through our situation. For us, t is what? T is the ping travel time. That's how long that ping was in flight. And so I don't want to write ping travel time every time, so I'm just going to call it PTT for ping travel time. Distance is the distance to the target. Distance. Okay. And rate for this is what? Well, what's traveling? A ping. A ping is a sound. How fast does sound go? Sound goes at the speed of sound, which is 767 miles per hour. Now, this is what you got to be real careful of. If I say D is equal to our rate, which is 767 miles per hour, times the time, which is ping travel time, and you've got to put your units in. Ping travel time was in what? Seconds. And we want to keep all of our units as a fraction. So seconds is just the numerator, so we're going to go ahead and put 1 in the denominator. So each term has a numerator and each term has a denominator. So I can't just come in and take 767 times ping travel time, because 767 is in miles per hour, the time unit is hours, and ping travel time is in seconds. And if you look, seconds don't balance hours, so we've got to correct this equation. What's the other problem? If we just corrected for time, then our answer would be in what units? Our answer would be in miles, and it's not very useful to have this thing read 0.000067345 miles, right? With our desktop, we're going to be thinking in inches, all right? So we've got to convert that to inches. And the way you do that is something called dimensional analysis, and I've done an entire series of videos on dimensional analysis, so I'm going to show you how to do it here. But if it's not perfectly clear, then I need you to go back and look at that video. But what do we know? We want our answer in inches. Okay, what are our problem? This is in miles, so I have to deal with that. What's the other problem? I've got hours in the denominator and I've got seconds in the numerator, and those two don't cancel each other out. So I've got to multiply by terms that will make the units work. And in each case, we've got to multiply by a term where the numerator is the same thing as the denominator. So what's the first thing we want to do? Let's put all of our numbers over on the left, and then we'll leave our units to the right, and then we will make our units work. So let's just rearrange this by saying distance is equal to 767 times ping travel time, PTT, and then my units are miles per hour times seconds over 1. Okay, now I'm going to put some other terms out here, and these terms are all going to be multiplying by 1, multiplying by 1. Multiplying by 1. What's my first problem? My first problem is miles. And so let's deal with that. Do I want miles? No, I want inches. So to get rid of miles, miles needs to be in the denominator. 1 mile. And then I have to put something in the numerator that's the same thing. Well, 1 mile is what? It's 5,280 feet. Okay, now look what happens. Look what happens when we do that. When we do that, what happens is I have miles in the numerator and I have miles in the denominator. Miles over miles makes 1. They go away. But now what unit am I in? I'm in feet. but I want to be in inches, okay? So if I want to get rid of feet, I need to put feet where? In the denominator. 1 foot is what? 12 inches. Okay, now what happens? This foot in the numerator over this foot in the denominator makes 1. They go away. And so now what units am I in? I am in inches. And so that is very good. But what is my problem? My problem is I have seconds in the numerator and hours in the denominator. And so I have to make those match. So I'll do the same thing here. I'll change color, but now I'm going to deal with that's not a very good color. Let's see. I'm going to deal with the hours and the seconds. So what I can say is, what can I say? I want to get rid of hours, all right? So if I want to get rid of hours, it needs to go where? It needs to go in the numerator. So I know that 1 hour is equal to what? 3,600 seconds. All right, now when I do that, let's look what happened. This seconds and this second, seconds divided by seconds makes 1. That goes away. And then hour in the numerator, hour in the denominator, that goes away. And what am I left with? The only unit that I'm left with is inches. Do you see the magic? I don't even have to think. I've just got to get rid of the units that I don't want by multiplying by 1. Now, what do we have? We have distance is equal to 767 times the ping travel time. And let's look, I got rid of this, 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 and I just have 3 numbers. And so I have to multiply that. I can't just drop those 3 numbers. I've got to multiply that by what? 5280, got that taken care of, times what? 12. I got that taken care of, and then divided by what? Divided by the 3,600. So really, distance is going to be as simple as measuring ping travel time, and then after you measure ping travel time, multiply it by the speed of sound in miles per hour, and then multiply it by 5280 times 12 divided by 3,600. Write this down, and now what we just got to do is we just got to code that up. We just got to go over and code that up. But do you see, this is going to be easy because we did what? We did the math and sketched it out on paper before we jumped in and started trying to code. And so let's come over and see if we can get a code view going here. I'm going to have to do a little Windows adjustment. What happens is my Raspberry Pi goes to sleep, and when that happens, then it loses connection with the monitor. So I have to wake everything back up. But let's see if I can come over and find a nice view for you guys. I think maybe I can just come down to just a straight code view. And this looks pretty good. What I'm going to need you to do is go ahead. We're going to get this thing working, so we're going to fire up Thony. So we come up to programming and we come down to Thony, and then here is going to be our code. And let's see, it's opening up in, you can go ahead and save it. Mine opened up as echolocation. I think I'll save this file, save as, and I'm just going to save it as, let's call it distance, like that. Distance.py, and the .py is kind of important. And now our program is called what it does, which is good. Use a good naming convention. All right, so if we're going to be talking to those pins, we're going to have to import rp_i.gpio as GPIO. Now we're going to have a stopwatch. We're going to have to be timing that ping and looking, doing some timing. So we're going to have to import time. All right, now GPIO.setMode, since we're using the numbering scheme off the breakout board, that is what? That is the BCM numbering scheme. So we're going to have to say setMode GPIO.BCM. That means the numbers that we're using are going to be the BCM numbers. Now we've got to tell it which pins we're working with. It's going to be the trig pin, which is the trigger pin, and what did we say that was? 23. Then we have the echo pin, and what did we say that was? That is 24. So that's looking good. Now we've got to set up those two pins, so it's going to be GPIO.SetUp. And then what are we going to do? We're going to set up the trig pin, and that's going to be a GPIO.out. And then because we're talking to the trigger pin, then GPIO.SetUp set up echo pin, and that's going to be a what? GPIO.in, because we're listening to the echo pin, we're talking to the trigger pin. So that all looks really good. Now we need to go ahead and set up our try and accept so that we can gracefully leave. So we'll have it try. This is where we'll have all of our code, but let's go ahead and do our accept. And the accept is going to be a keyboard interrupt like that. And so when it sees the keyboard interrupt, it will drop down here. And then what do we want to do? We want to do a GPIO.clean up like that, and then we need to let us see that we cleaned it up, so we're going to print GPIO good to go like that. All right, forgot the ending quote there. So that looks good. Now we're ready to come up here and write the main code. So what do I need to do? I need to do a while true. When is true? True. True is always true. So I'm creating an infinite loop here, and it'll keep looping. It will keep looping until it sees the control C, and then it'll exit and clean up the program. Now, we have to send that start pulse to the trigger pin. So the first thing, the start starts at 0, it'll go to 1, and then it will come back to 0. So we're going to say GPIO.output. And where do we want to send it to? Trig pin. And we want to set it what? Low or 0, like that. Then we need to wait. So we're going to say time.sleep, and we're going to wait 2 microseconds. How do we write 2 microseconds? Well, you could put 0.000002, or you could say 2 e to the minus 6. And that's e to the minus 6 is micro, and it's a lot easier to put e to the minus 6 than it is to count zeros. All right, now that we put it at 0 and waited, now what do we need to do? We need to put it at what? At 1. So now it's high. Now we've got to leave it high for a little while. So I'm going to say a time.sleep. And this time I'm going to leave it high for 10 e to the minus 6, which is 10 microseconds. All right, so that looks good. And now we need to set it back to 0. GPIO.output, and then the, that would have been bad. Trip pin, no, trigger pin. Okay, trig pin. And this time it is going to go to 0. Now, our stopwatch does not start when our trigger signal goes to 0. Our stopwatch starts when the echo pin goes to 1. Does that make sense? When the echo pin goes to 1. So what do we need to do? We need to read the echo pin, GPIO.input. We're going to read that, while GPIO.input of what? We're reading the echo pin, okay? While GPIO input of echo pin, while that is 0, we do what? Absolutely nothing. We wait. So this is just going to sit. So we are going to give it the trigger signal. It's going to sit and wait in this while loop, looping until what? Until it sees echo pin go high. And then when it sees echo pin go high, then it's going to drop out of this loop. So it's just going to hang there until the echo pin goes high. Now what do we need to do? We need to start our stopwatch. And how do we do that? We go out by grabbing the system time. So that's going to be echo start time, and that's going to be equal to time.time, and that is just the time on the present system clock. Now that it has gone up, what do we want to do? We want to wait until it comes back down. So we kind of do the same thing. Now, while GPIO dot input of echo pin, while that equal 0, no, while that's 1, because it went from 0 to 1, and now we're just sitting there looping while it is high. So as long as it's 1, we're just going to sit here, not do anything at all, but just wait. And then when it comes back down, then the echo pin will be 0 again, and it will come back out. Now that it comes back out, what do we need to do? We need to stop our stopwatch. So we're going to say echo stop time is equal to time dot time. All right. Now we need to figure out, and I'm just going to call it PTT, ping travel time, because it's easier to write. The ping travel time is equal to what? How long was that ping out there flying through the air? Well, it was flying through the air between echo stop time minus echo start time, and that's going to be the ping travel time. Does that make sense? I hope it does. So now I know the ping travel time, and that is kind of like 90% of what we need to do. But now what I need to do is I need to calculate distance, and that is, if I look over here, let me go back and take a look over here again. Remember this equation. It's 767 times ping travel time times 5280 times 12 divided by 3600. And so what I'll do is I'll come back over here to the code view, and now we're going to give that a try. So I'm going to come here, and I'm looking at it. Hopefully you guys wrote it down, but it is going to be equal to ping travel time, okay, or I think I put 767 first, so it's 767 times ping travel time, okay, times 5280 times 12 divided by 3600, and now that is my distance. So now I'm going to print, and I'm going to go ahead and round distance because I don't want like 8 decimal places. So I'm going to say round the distance to 1 decimal place, and then I'm going to say add to the end of that inches. So I'll have the units. All right. Now, could it really be this easy? Could it really be this easy? Now, let me ask you guys, how many of you got this far? At least how many of you saw that distance is rate times time, and that you were going to have to convert miles to inches, and you were going to have to convert hours to seconds? How many of you got that far? Leave a comment, or if you're in the live chat, comment and say how many of you guys were able to get this far. Okay, good. So now the question is, let's see what happens. So I'm going to come over, and I'm going to put a target here. So I'll show you the overhead shot in a minute, but I'm going to put a target here. Let's see. All right, I got a target in front of it. And now I'm going to run the program. I will need you to hold your breath. Denied. What is that nonsense that it doesn't like GPIO good to go? What could possibly be wrong there? Let's come over here and see. What did I do? That sure look. Oh, I put a double quote and a single quote. Those, they can be either one. They can be either one, but they need to balance. Okay. Someone didn't hold their breath this time. Whoever you were, I need you to hold your breath. Okay, what did I forget? Oh, why did that just do one answer? Okay, I'm going to do a Control C, and I have while true, and everything is inside of the while true. So that all looks good. It seems like it just ran one time. Oh, I think also it would be very good form if I put a delay in here, just so that we're not hammering the sensor too quickly. because when you send that ping and it comes back, there could be some echoes in the room. And so what we also need to do is do a time.sleep, and I would say about 0.2 seconds. All right, so now hold your breath. All right, boom, there it goes. Okay, now you see I'm getting a good solid 9.2 inches, and I'm going to take you to the overhead view so you can see my setup live. And let's see, where is that nice little one? Okay, that shows you my setup, but doesn't show you. Let me get this where you can see things a little better. Okay, so that's about 3 inches. Things must be perfectly square in order to preserve parity and unity in the universe. We must keep everything perfectly square and neat. Okay. Where is that little gizmo where I show you that with a... here it is. Okay, let's show you this one. All right. Now, there it is. Boom. It's measuring 6.2 inches. And if I look at the ruler, I'm going to get this lined up better. So I'm going to kind of go to about the middle of the barrel. And then I'm going to put this very carefully here, as closely as I can to 3 inches. And I am measuring what? Let's see, let me get this. Okay, so I'm just almost right at 3 inches. And what am I measuring? I'm measuring like 6 something. Well, let's go to 2. At 2, I'm measuring something like 4 something. I'm not sure, that should be a little better than that. Okay, what if I try to go to 1 inch? Okay, at 1 inch, I'm measuring something like 2. I'm not sure why I am off. Maybe I need to adjust my ruler a little bit better. Yeah, I need to get it in there at about the middle of the barrel. And now if I come to 3, I'm measuring what? I'm measuring 6. So how many of you had this same problem? It seems to like almost work. If I'm at 2, it measures 4. If I come out to 4, it's measuring about 8. It seems to be working amazingly well, but it's what? It's off by 2. Okay, be honest. How many of you had this problem? If you had this problem, leave a comment down below. GAC. Guilty as charged. Were you guilty as charged and got a answer that was twice too much and consistently twice too much? It's not like it's just off. It's always off by a factor of 2. How many of you got that? Okay, of you that got it, how many of you were able to figure out what the problem was? Okay, what is the problem? Okay, what is the problem? I'm going to give you a second, you guys that are in the live chat, give you a second to see if any of you, first of all, had this problem. And those of you who had the problem, did anybody figure it out? Okay, what you have to see is ping travel time is what? The amount of time the ping was traveling. Where did the ping go? The ping went from the emitter to the target and what? And back. So the distance traveled to the ping is what? It's twice the distance to the target. So I am not measuring the distance from here to here. I'm measuring the distance from here to here and the return trip. And so what does that mean? The distance to the target is half the distance that was traveled by the ping. I love this problem. I'm telling you guys, I cannot tell you. When I was teaching students in high school, 100% of the time they would make this mistake. And they would go crazy trying to figure it out. Okay, what is it? Like, what went wrong? Well, are you wrong on the speed of sound? No, you can find speed of sound in 1,000 different places. The speed of sound is the speed of sound. That wasn't the error. Is the sensor bad? Well, no. If the sensor was bad, then what would happen, you would be getting random errors or a constant large offset error. You wouldn't be getting perfect results off by 2. Well, does distance equal rate times time? Yeah, go back, review your physics books. Distance is equal to rate times time. But where was the mistake? The ping doesn't just travel to the target. The ping travels to the target and then it returns. So this is not, this isn't cheating, and this isn't just making it work. But what do we know if we want the distance to the target? In fact, let's do that. That's the total distance traveled. Let's say the distance to the target, dtt is equal to distance divided by 2, because the distance traveled by the ping, it makes the trip twice. You've got to divide by 2. So I can do a Control-C, and let's come back and run this again. And then we're there. Let's come back to this neat view where I can see the numbers and the setup at the same time. So now, as you gotta not only do the correction, you also have to print the corrected one. So now I corrected it, but what I want to do is I want to print DTT, the distance traveled. So we'll try that again. We'll hit run, and we'll come over here. And look at that. So I'm going to come back to this cool view, and you look here, and I'm right at 4 inches, and it's reading what? It's reading 3.9 inches. As I bring it up to 3, trying to keep it really careful, look at that. It reads 3. It's magic. Okay, it is magic. Let's see if we can go to 2. Okay, I need to get it right at 2. Okay, and as we get really close, you can see that it's not quite as accurate. It's reading a little bit low, and I found, well, that's pretty good. I found that at the very short distances, like somewhere between 1 and 2 inches, it stops working very well. You won't see this, but I'll come out to 8. Okay, I'll come out to 8, and let me get it right on 8, and there it is. It's reading 8, and let me even see if I can back this off and show you. Yeah, you see I'm at 8 inches, and then it is working very well. So I'll bring the view back in. Okay, so now what you can see is this thing is working great. Now, those of you guys who are in the, you could see that you could make a portable distance sensor with this, a portable distance meter with this. You'd need to hook up your little LCD screen, and then you would need to run the Raspberry Pi off of like a USB, like one of those USB phone chargers, one of those battery banks. And then you would need to like 3D print a nice case for it. But you see, you're getting the skills now of where you could really do some really neat stuff. Now, guys that are taking the Raspberry Pi class, man, I really hope you'll go over and take those Fusion 360 with 3D printing lessons, because before this class is out, we're going to want to start making little projects. And to have a little project that doesn't just sit on the bench top, you're going to need a case or a housing for your project. And so it would really be great if you had the skills of the Raspberry Pi, plus you had the skills of Fusion 360 and printing. Is this pretty neat or what? Okay, guys, I hope you had as much fun taking this lesson as I did making the lesson. And what I also hope is, I hope you guys are doing the homework, and I hope you're leaving comments down below. And I really want to see how many of you struggled with this issue of being off by a factor of 2. All right. I really want you to think through these things, and I want you to think through dimensional analysis. And so I think I'm going to give you one more homework assignment with this sensor. And what your homework assignment now is, your homework assignment is to build a little device that will actually measure the speed of sound. So you've got to pretend that you don't know the speed of sound. And you know, like if you yell and you hear it go out and hit a barn and come back, you know that sound is kind of slow and it takes time. But I want you to develop an experimental setup with your Raspberry Pi and your Sunfounder kit and your newfound knowledge and wisdom, and make a little device that will measure the speed of sound for you and report the speed of sound. And let's see how accurately you can get to what the published values are. But you can't go in and put in there the value that you know it is. You have to put that to the side. You have to do an experiment and then calculate the speed of sound. And then you got to go back and check it with the known and published speeds of sound. Okay. All right, man, guys, I'm having a lot of fun with this. I'm also having a lot of fun with the Fusion 360 lessons. If you enjoyed this, give us a thumbs up. That'll help us with the old YouTube juice. If you haven't subscribed to the channel already, make sure you subscribe. Ring that bell after you subscribe so you get notifications. And then share this with your friends, because the world needs more people doing coding and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.